The HydroFlex project aims to increase the value of hydropower through increased flexibility. The project will develop technology for hydropower plants that permits faster ramping rates and 30 start-stop cycles per day.
In 2050? Wow. I expect actually that hydropower will have a role of having stability, giving stability requirements, security and reliability into the system, but especially be the one that actually brings stability.
Increased electrification and transition from hydrocarbons to renewable primary energy sources is two key pathways to fulfill our climate commitments. Intermittent renewable sources such as wind and solar will challenge the stability of the power grid. Flexible hydropower can be one of the pathways to facilitate the energy transition. A well-functioning power system requires that for all time there is a balance between power production and power consumption. Imbalance will cause disturbance in the system frequency. If not corrected, this can lead to a cascading failure. In a hydropower plant with reservoir, the output can be controlled and rapidly change in response to variations in the power system. In a future European power system with a large fraction of intermittent renewable energy and electrification of transport and industry, flexible power sources will have increased value.
Work Package 2 is led by the Institute of Power Systems and Power Economics at RWTH Aachen University in Germany. This work package defines the scenarios and reference cases in the HydroFlex project.
Our aim is to evaluate the flexibility provision in the future European power system. And upon that, we want to derive the future operational requirements hydraulic power plants have to meet in the future. And therefore we perform computational simulations to simulate the European power system regarding the market, the grid and stability issues.
At this point, Work Package 2 has gathered feedback from all contributing partners into future scenarios. This has established the groundwork for simulations in other HydroFlex work packages.
Work Package 3, Flexibility of Turbines, is led by the Department of Energy and Process Engineering at the Norwegian University of Science and Technology in Trondheim. In this work we investigate the impact of 30 start-stops and fast ramping rates on the turbine design. The main deliverable of Work Package 3 will be new turbine design for variable speed operation, design of devices to mitigate part load oscillations and a model for turbine life estimation.
We actually aim to design a new turbine, which is a new concept, and that accommodates variable speed technology as well as a high ramping rate. That means if you talk about the car which has only 4 shifting gear, but if you have 5th gear, you will be able to drive fast and manage a car easily. That's where the 5th gear is variable speed technology in hydropower.
Work Package 4, Flexibility of Generator and Converter, is led by the Division of Electricity at the Department of Engineering Sciences at Uppsala University, Sweden.
The existing hydropower is more efficient and more adaptable to what we do have today. But at the same time, the lifetime of these components is so long, so we also have to think, okay, how can we change what we have today, but we also have to look in the future, what will hydropower look like in 20 or 50 years, because that's the time plan of the lifespan of the installations.
Combining synchronous machines with frequency converter, including novel control of the magnetization system and improved insulation, leads to more flexible generator configuration. This will improve start and stop performance and enable the ability to provide strong ancillary services to the grid and minimize component wear.
I hope that the HydroFlex project can bring the technology forward in the sense that we can show back to the European Commission that hydropower really can provide very large and significant flexibility.
Work Package 5, Social Acceptance and Mitigation of Environmental Impact, is led by the Department of Engineering Sciences and Mathematics at Luleå University of Technology, Sweden.
I think one thing is that we really work together towards a more useful hydropower and also more environment accepted hydropower. So this is one thing, and that we generate new tools that can be used to reach this goal that we just talked about.
The objectives of the work package are: develop technology for active storage of water that will enable high ramping rates and minimize the negative effects from the discharge into the downstream river. Investigate the influence on river ecosystems subjected to 30 start-stops per day, with and without mitigation. Explore socio-economic and environmental aspects of user groups/stakeholders from high ramping rates, through a survey of public resistance and acceptance to 30 start-stops per day.
HydroFlex is one of our largest international projects.
The HydroFlex project is supported by the European Union Horizon 2020 research program.